So good afternoon. Yeah, there's nothing more to say about me except that I like solving complex problems, and as it is my pleasure to entertain you after lunch or keep you awake maybe, I'm going to try and be a bit controversial. I'm going to talk about many things. I'm going to give lots of examples, and I'm going to try and avoid software, and I'm going to try and avoid UML. Sorry, Ed, if Ed is here. And SysML and so forth. I'm going to try to take you out of your comfort zone and thus keep you awake. No? Okay. So, as Bran pointed out, the last 4 years we had a European cost action. Cost is a funding channel for bringing people together. That's the one of the 2017 meetings in Malaga, where we basically discussed multi-paradigm modeling for cyber-physical systems. And as is often the case with these projects, towards the end of the project, you start figuring out what it is about. So we've spent 4 years trying to figure out what multi-paradigm modeling is, and we now have a bit of an idea. Actually, we got to a point that became concrete enough to have, and that's what you see in the bottom, to organize some training schools and to have young researchers really apply model-based system engineering in all its glory, using multiple abstractions, multiple formalisms, model transformations, and so forth. Okay, and so that's what this talk is about. So the talk is mostly about multi-paradigm modeling, and okay, it's for cyber-physical systems, which really stands for complex systems. And the running definition that we use is that cyber-physical systems emerge from networking of multi-physical, so it's mechanical, electrical, hydraulic, biochemical, and so forth, and computational, which could be control, signal processing, logical inferencing, planning processes, often interacting with highly uncertain environments or with a highly uncertain environment, including human actors who are highly unpredictable in a socio-economic context. And of course, because most of us are software people, software plays a really important role, not only because software is a component in such cyber-physical systems, but also I'm at heart a tool builder, because the tools that we build to help engineers design such systems are going to be typically software tools. Okay, and let me point out, it says there at the very bottom, we're talking about engineered systems. The really tough stuff is when you try to understand how the human body works, for example. That's science. What we do is we take results of science, we combine them, and we try to engineer systems. And that gives us sometimes a bit of control that you don't have as a scientist. Well, it gives us a lot of control that you don't have as a scientist. Okay.